Guys, hope you are doing well. I'm Kumar K, your favorite DSA teacher. When it comes to solving hard unseen DSA problem, which requires lots of complex logic and intuition, okay, hard unseen DSA problems of online assessments, online tests of top tech companies, and competitive programming and coding contest problems. Today, I'm very happy. Think why I'm happy. I'm always happy when my students get selected. So, guys, if I go to the document, this document link will be there in the description of the video. Okay, many of you keep on asking me where is the material is in the description of the video. So guys, the first thing, congratulations to my student for cracking a great offer, very high paying offer off campus from Amazon. Okay, despite not being from a top tier college, she cracked it off campus. My student did it. Congratulations to Sukriti. She has been training very hard with us for DSA, OA, CP, one-to-one mentoring, referrals, everything combined. After 8 to 10 months of hard work, Sukriti has generated the offer. She was a beginner few months back, but now she is awesome at DSA, OA, CP, and she has offer from Amazon off campus. Similar to her, guys, 2 days back this happened, and then 5 days back another student of mine cracked off campus offer from Amazon. Like, there have been so many selections in so many companies, but in today's video I'm thinking of mentioning the Amazon one because it reminds me of my days when I got the Amazon offer a few years back. I was very happy. So Harini, congratulations for cracking off campus offer. She has worked hard since 10-15 months. I know her. I know her struggle. Then, guys, congratulations to Abhirami as well. She has also cracked a very great offer from Amazon. So, congratulations to her. Great job. Great job. So, like this, on a daily basis, we have many selections. Okay. Now, coming to my introduction, I have previously worked at Amazon and Mia.net as a software engineer. And coming to our love for DSA, I have All India rank 12 in Google Code Jam 2021 and All India rank 4 in the recent Facebook Hacker Cup. So, guys, if you want the best level DSA plus OA plus EB training in the country, you can join our one-to-one mentoring and personalized training program, where all the live classes are by me, and you get the one-to-one mentoring with me as well. Also, you'll get full stack development feature, system design training feature. You will get referrals of top 500 companies. Many things are there, and we have selections on a daily basis. So if you are interested, you can check the link in the description. We have special offer of New Year on the new batch which has been getting launched. Now, guys, today we are going to solve very interesting problem. Everything is making me so happy today. So hello guys, with the name of God, Ram Ram. So many students gave the ServiceNow online assessment for SD intern and full-time SD role. Okay, and this online assessment happened on 25th January, and a very difficult tree problem was asked in the test, and many students faced lots of problem in solving this question. See, Ram, what generally happens is that in online assessment they ask you a story based new unseen DSA question, and generally it's hard only. Okay, so the thing is that people only keep on doing the standard questions of lead code GFG, and they do standard popular DSA sheets standard questions. So if you only do standard stuff, your thinking skill will never develop. When your thinking skills do not develop, you are not able to tackle the new unseen hard questions of the online assessments of the top tech companies. And then you are not able to succeed in them. So, as the years are going ahead in the interviews and the OAs, the questions which are coming up, they are harder and harder and harder. Okay, so that the actual thinking skills and the problem solving skills of the person can be checked. So, in this problem, the thing is that I will try to teach you in such a manner that you are able to use your own thinking skills to solve this problem. So, first of all, this problem is based on tree and dynamic programming on tree. So, the first thing we should know, what is a tree. Tree is a structure which looks like this. Tree always has, let's say, n nodes, and there are n minus 1 edges. Node 1, node 2, node 3, node 4, node 5, node 6. So you can see that there are 6 nodes, okay, and there are n minus 1 edges. There are 5 edges. See, edge 1, second edge, third edge, fourth edge, fifth edge. So tree always has n nodes and n minus 1 edges. Okay, and it is always a single connected component. Okay, that thing also you understand. And there is no cycle. So if you start traveling from one node, you can never reach that node again. So if I start traveling from 2, I'll go like this, like this, like this. I can go anywhere, but I can never reach 2 again. So cycle is never there in the tree. So hopefully the basic definition of tree is clear to you, lovely people. So now what the question is saying, that we will give you a tree. We will give you a tree. Divide it, divide it in maximum groups of part 2. Okay, maximum groups of part 2 of size 2. Okay, so guys, we have to divide the tree in maximum groups of size 2. Okay, so hopefully you got a little bit idea what I was trying to say, that you are given a tree is a graph with n nodes, n minus 1 edges, single component. Tree is rooted at node 1. So guys, please remember the child and parent relationship. Whichever node, see, these are the nodes, right? So what is the root of the tree? The topmost node, this guy is called as the root of the tree. Okay, so this is, let's say, 1. Now guys, to solve this question now, you need lots of prerequisite knowledge. Like you need to know about tree, you need to know about DFS on tree, you need to know my special tricks of DP and DFS on tree. Okay, if you are a student of my 800-hour course, you will know that. And you also need to know the special trick of bottom DFS traversal, DFS bottom traversal type. So if you don't know these things, I will add these videos in this document. This document, okay? In this document, here only I will add these videos. Watch those videos, then you watch this session, okay? So first you watch these videos, which I will add in the Google document. The link to the Google document is in the description. Then you come to this class, okay? So now let's assume that you have watched all those videos and you know all the ways to travel the tree, DFS tree, DP on tree, and all the basic things, you know. So you must also be knowing that the top most node is the root of the tree, and this is a child-parent relationship, right? You can say that node 1 is nothing but parent of node 2. Node 1 is parent of node 2, and okay, and node 2 you can say is child of node 1. Similarly, you can say that node 1, node 2, node 3, node 4, node 5, node 6. Okay. So what is the relation between node 5 and node 6? You can say that 5 is parent of 6 because 5 is above 6. Okay. What is the relation between 3 and 6? You can say that 3 is the grandparent of 6. Why? See, this is the parent of 6. So above parent comes the grandparent, right? So lovely students, this guy is the parent and that guy is the grandparent. So you can say that node 3 is a grandparent of node 6. Now what is the relationship between node 3 and node 1? This guy is the parent, this guy is the grandparent GP, and this guy is the great grandparent. And guys, you know, it could have gone above and above and above like that. So node 3 is the great grandparent of node 1. So guys, whenever someone is a parent or a great grandparent, or let's say or a great 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 grandparent or something like that, whenever the node is having this type of relation, now you can say that node 1 is nothing but, you can always say that, okay, so in our case, what is the relation between node 6 and node 1? You can just say that node 1 is nothing but great great grandparent of node 6. This much concept is clear in your mind. Okay, nice. You can also call it as an ancestor. Ancestor means if you go above from this node and you are able to find some node, that node is the ancestor of the node from where you started. Okay. So these basic things you should know, and hopefully you guys know these things now. Okay. If I take any two nodes and I ask you the relationship, what is the relationship? 1, 5, 2, 3, 4. What is the relationship between node 1 and node 5? What is the relationship between node 1 and node 5? So I know node 5 is at the bottom. So this is parent and this is grandparent. So you can say that node 1 is grandparent of node 5. But instead of grandparent, you can also call it as ancestor. Ancestor means what? Ancestor means that either it can be parent or it can be grandparent or it can be great grandparent or it can be great grandparent and some like all the possible variations. So if there is any kind of this relation, now you can directly call it as an ancestor. Okay. So guys, we are given a tree. So lovely people, hopefully this basic concept is clear to you that we are just given a lovely tree with us. Okay, we are given a tree. Now we want to divide this tree in maximum possible parts. Okay, so how will we divide the tree in maximum possible parts? This is a very hard tree question, but you can do it, trust me. So let's take this tree. Okay, they are using node number 0, but we will use one based indexing. Okay, so this node is having the number 0, another node is having the number 1, another node is having the number 2, another node is having the number, okay, 3 and 6, and then there is 0 1 4 5. So guys, how can you divide this tree in groups of size 2? How can you divide this tree in groups of size 2? So what they are saying is that tree is rooted at node 1. Divide the tree in groups of size 2 such that if x and y are in the same group, then x and y should have no parent child or ancestor or distant parent child relationship. So the two nodes should not be ancestor of each other in some way. Then only you can put those two nodes in a group. So let's say you try to say, sir, can I make the group of 0 comma 1? No, because there is a child parent relationship, not allowed. You have to make group of two nodes. Can I make the group of 0 comma 4? No, why? Because 0 is the grandparent of 4. So child ancestor relationship is coming here. Descendant ancestor relationship. So if someone is a parent or a great grandparent or a grandparent or ancestor, you cannot put both of them in a group. Okay. If you are putting X and Y in a group, then there should be no ancestor relationship between them. So 0 and 4 also you cannot put. Can you put 2 and 6 in a group? No. Why? Because again, this is the parent and this is like the grandparent. So no. Can I put 3 and 6? No. Because again, there is a child parent relationship. Can I put 4 and 5 in a group? Yes. Because 4 and 5 are not ancestor of each other. You can go and travel in upwards. You come here, You come here, you will never find a 4 if you keep on going upwards to find your ancestor. So 5 does not have ancestor as 4. And also for 4, if you keep going upwards, you will never find a 5. So 4 and 5 is a valid partition, guys. It's a valid partition. It's a lovely, lovely valid partition. Okay. So guys, they are saying that try to make maximum number of partitions possible. Okay, like try to make maximum number of groups of size 2. See, it's written in the question also. So one thing what you will do, you will put 4 and 5 in this group. Now guys, use other nodes and make a group. So these two nodes can be put in the same group because they don't have any ancestor or descendant or child parent relationship. Another thing what you can do, I can select this node and this node. They don't have any parent child relationship because if in 6 you keep on traveling upwards, you will never find a 1 here, and if you keep on traveling upwards, you will never find a 6 here. So 1 comma 6 is also a valid partition. Now can I make, so 4 has been used, 5 used, 1 used, 6 used. Can I use 2 and 3 together? No, they have child parent relationship. Can I use 0 and 3? No. Can I use 0 and 2? No. So only two groups we are able to make. From this tree having n nodes, we are able to make only two groups till now. Okay, but there is a better way. We can create more groups. So that is what the question is saying, that divide the tree in groups of size 2 xy such that x and y have no parent child or distant parent child relationship. Okay, task is to create maximum number of such groups. Your task is to create maximum number of such groups, guys. Okay, task is to create maximum number of such groups. Okay, so what to do? We are made only two groups. Is there a way to create more groups? Yes, you can create three groups, guys. 4 5 1 6 is one of the way, but you can create three groups. You can select 1 comma 2. They are valid, right? Because they don't have any child parent relationship or ancestor descendant relationship. Then you can select 4 comma 3. Then you can select 5 comma 6. All are valid. They don't have any child parent or ancestor descendant relationship. So you are able to make three groups from these 7 nodes. Three groups means total 6 nodes have been used because each node have two people, right? Each group has two people, two nodes. So you are able to use maximum number of nodes from the given nodes. That is the task of the question. Given these node and this tree, this structure, select maximum nodes and make valid groups from them. So for any tree of having n nodes, n minus 1 can be the maximum answer possible if the tree is a good tree. Okay, so guys, why n minus 1 can be the best answer? Answer can never be n. Why? Because root node can never become part of any group. Root node can never become part of any group. Guys, can you use your brain and tell me why root node can never become part of any group? I make group with 0 comma 1, this is will also not be valid. I make 0 comma 2, this will also not be valid. I make 0 comma 4, will not be valid. 0 comma 5 will not be valid. With 0 I try to pair anyone, it will fail only. Why? Because this is the root node. This guy is the ancestor of all other nodes. All other nodes, when they travel upward, they reach 0. They travel upwards, they reach 0. They travel upward, they reach 0. So all guys can say that either this 0 root node is my parent or great grandparent or grandparent or something like that. So 0 is always the ancestor of all other nodes. Why? Because it is at the top. It is the root node. So it can never come in any group of size 2 because it will always have some ancestor relationship. Okay. So this means that in the best case, what can you do? In the best case, intuitively, guys, develop your problem solving skills. In the best case, what you can do is you can make group of this guy and this guy. Okay, and this node will remain as it is because nothing can happen, and these guys can, make relationships with each other. Like these guys can make groups with each other, not relationship. So the thing is that this node will always be left out. So if the total number of nodes are n and this guy is left out, then n minus 1 nodes can make groups, right? We are assuming that if they are able to make groups, then the answer will be n minus 1 by 2. Okay. If all of the n minus 1 nodes are able to make the groups with each other. Now guys, this thing is clear. Now guys, to solve this problem, we will use DP on trees. Okay. So generally this technique is not taught to the people, but I have taught this technique to my students in the 850-hour course, especially in the tree plus DP section, in a very brilliant manner with many OA and CP problems. Okay. So if you don't know the trick, don't worry, I will attach some videos, you can watch that. Whenever we have to solve the question like this, na, we always start traveling the leaves. We do the bottom up traversal. First, we will travel the bottom values, then we will travel the upwards values. So first, we will travel this guy, this guy, this guy. It is called as bottom up DFS. Then we will travel this guy, this guy, this guy, this guy, then the root node. So let me tell you how we are traveling in the bottom up traversal. I will attach videos on how to write code for it, but you can just for now understand that there is some kind of bottom up traversal which exists in this world. First, I will travel this node, then I will travel 7, then I will travel 6, then I will travel 5, then I will travel 4, then I will travel 3, then I will travel 2, then I will travel 1. I will travel 8, then I will travel 7, then 6, then 5. So from bottom I am going up. Okay. So guys, what is the use of bottom up traversal? The use of bottom up traversal is that we will be having a DP array, and DP of I will tell me the answer for subtree, answer for subtree at node I, if node I is considered as the root. Okay. So what we will do, because we are traveling bottomwards, na, see. So what will be the meaning of DP of 8? DP of 8 will tell us what is the best answer to the question if only this was your tree. What would be the best answer? 0, right? Because this guy cannot make a group with any other node because only this is the tree. Similarly, DP of 7 will tell me what will be the answer to the question if only this much part is your tree. If only node 7 you have. How many groups you can make? 0. So DP7 is also 0. So DP6, deep sea carbon, right? Anyways, humans have the imagination power which no one, which other creatures and other machines don't have. So always believe in Einstein's word and have the power and the capability to imagine. So, anyways, guys, DP of 6 means the answer for this tree. What will be the meaning of DP of 5? DP of 5 means the answer for this tree. DP of 5 means the answer of this tree. If the tree was only looking like this, then what would be the answer? How many groups you can make? You can make one group, right? You can select 6 and 8. 5 and 7 you can never select. 6 and 8 are not having any parent child relationship. So DP of 5 is 1. You can make one group of 2 nodes. So DP of 5 means the answer for the tree if the tree was starting at node 5. What is the meaning of DP of 4 if the tree was starting as 0? What is the meaning of DP of 3? If the tree was starting at node 3, if this was your tree, 3, 4, then 5, then 6, then 7, then 8. So which parts you can make or which groups you can make? You can make one group with 6 and 8. One group you can make with 4 and 7, because 6 and 8 are not having ancestor relationship. 4 and 7 also having no relationship, right, of ancestor. So two groups you can make. So DP3 is 2. Similarly, DP2 means this. What if this was your tree? DP1 means the answer for the whole tree. So guys, the final answer will be DP1 only. Because DP1 gives us the final answer. No one will teach you in such a brilliant manner. I'll put all my heart and energy in making you very, very strong. So DP1 is nothing but the final answer. Okay, great job. Nice. So guys, what is the final answer? If DP1 means answer to the question if 1 is at the top. So we assume that 1, see, we are assuming in this question that tree is rooted at node 1. But in the actual question which was asked in the GFG platform for the ServiceNow OA, they were assuming 0 index. Okay, 0 index. We are assuming 1 index. They are assuming 0 index. So that should not be a problem for you. Why I'm assuming 1? Just to keep things easy. Okay. I like using 1 to n rather than 0 to n minus 1. So DP of 1 tells the best answer to the question if the tree is considered at the root node 1. Root node is always number 1, okay, at the top. So for DP1 guys, how many groups you can make such that there is no ancestor descendant relationship between those between any two nodes in the group which you have created. So you can select, I think is you can select 2 and 3. Then you can select 4 and 5. And you can select 6 and 8. So all nodes used only 1 and 7 got remaining. You cannot add 1 and 7 because 1 and 7, they parent, they have ancestors and that relationship. And 1 can never make any relation with her because 1 is the root node, right? So 3 groups you are able to make. So lovely people, DP1 is 3. And that is the final answer. So now let's see guys how to calculate these values. So hopefully you understood guys that the trick is that first you will calculate DP of the bottom nodes by doing bottom up DFS traversal. Then finally you will calculate the answer for this node. Now why are we going from bottom to up? Because the answer for the bottom parts will help us to calculate the answer for the top part. So these things are done. So here also we can see that divide the tree in groups of size 2. Task is to create such that x and y have no parent-child or distant parent-child relationship. Task is to create maximum number of such groups. Root node can make pair with any other node, cannot make pair with any other node as all other nodes are below it, which means they are its children or distant children or in some way. Do post-order traversal DFS. So first we travel leaves, then the upper node, still the root. Okay. So guys, for node 1, let's say we have done the post order traversal DFS, and using that we have calculated how many nodes are there in each subtree. Okay, so for node 1, let's say there are 5 children and the problem will be solved so easily. Let's say this is node 1, this is the child C1, this is the child C2, this is the child C3, this is the child C4, this is the child C5. I want to calculate DP of 1, or you can say answer of 1. Okay. Now you know that the tree looks like this. Okay. So you know one thing guys, what? Count of C1. Count of C1 should tell me, I assume that we have this array pre-calculated while we were doing DFS in the past. Okay. So one DFS is done and we know the count of C1. Count of C1 means how many nodes are there if the tree starts at C1. So one node, two nodes. So from here there are two nodes. In this part, in this subtree there are two nodes. So count of C1 is 2. This subtree has two nodes. This subtree also has two nodes. This subtree also has two nodes. This subtree also has two nodes, and this subtree also has two nodes. So how many total nodes are there? D equal to 2 plus, like how many total nodes are there below 1? 2 plus 2 plus 2 plus 2 plus 2, 10. What is the maximum of all the numbers given here? Maximum is 2 only, right? If you take maximum of all the subtree total number node, here there were 2. 2 max of 2 comma 2 comma 2 comma 2 is 2. So that basically means that when the maximum, guys, if you consider all the subtrees, okay, and the total number of nodes in them is d. If the maximum is less than equal to d by 2, then the dp1 is nothing but d by 2 only. बेसिकली मेरे कहने का मतलब क्या है ना, if you count all the nodes below you, okay, you count all the nodes below you, their sum is d, okay, but each subtree size is less than equal to d by 2. It means they can always be merged with each other, they can always make pair with each other. So I'll try to explain it to you with one more example. Let's say this is one, okay, the tree looks like this, okay. So how many nodes are here? Two nodes. How many nodes are here? Two nodes. What is the total of the things below 1? 4 are there. What is the, if I take maximum of each subtree, one, like this one has this child, right? So maximum of count of C1 comma count of C2, and count of C1 means how many nodes are there including C1 and below C1. There are two nodes. And how many nodes are there including C2 and below C2? So there are two nodes. So the maximum is what? 2, which is less than equal to d by 2. This means that it is a mathematical concept. They can always make pair with each other. If the maximum of all of them is less than equal to d by 2, they can always make pair with each other. How can they make pair with each other? Guys, you can intuitively feel why they can make pair with each other. अरे तुम ही दिमाग लगाओ ना. This node will make pair with this node. C1 comma C2, and let's say this node was X and this was Y. C1 will make pair with C2, guys, because they are from different subtree, na? Because they are from different subtree, they will never have any ancestor descendant or parent child relationship. C1 can make pair with C2 and X can make pair with Y. So total how many pairs? D by 2 pairs are becoming. All 4 nodes have been used. If you are using all the D nodes, how many pairs will be there? D by 2 pairs. Done. So basically I'm saying that they can always make all the nodes below 1 can make pairs with each other if the maximum count is less than equal to d by 2. Okay, so let's take a even better example. 1 2 3 4, let's think 4 5 6 7 7 8. Yeah, let's make it like this. What is the total number of nodes below 1? Here it is 4. 4 nodes are there. Here there is 2 nodes, and here there are 2 nodes. So total number of nodes is 4 plus 2 plus 2, 8. What is the maximum, guys? If you try to take maximum of all of them, maximum of 4 comma 2 comma 2, it is what? 4, which is less than equal to d by 2. D is 8, 8 by 2, 4. 4 is less than equal to 4. It means they can be merged without any problem. They can be merged without any problem. These lovely nodes can be merged with each other without any problem. Such a nice, brilliant thing to know. Wow. This is a mathematical concept, guys. If the maximum of all of them is less than equal to d by 2, इसका मतलब वो एक दूसरे के साथ जुड़ सकते हैं. मतलब आंसर क्या होगा? It means dp of 1 means the answer for the tree starting at node 1 is nothing but d by 2. But this answer is only true if and only if and only if the maximum of C, like whatever the children are, C1, C2, C5, you should know their count, like how many nodes are there in C1 and below C1. How will you know that? You can maintain a count array. You can do a DFS, which will tell you the count. And if you don't know how to do those things, you can watch the videos which I will add in the document. So you know, 4 nodes here, 2 nodes here, 2 nodes here. So if the maximum of them is less than equal to d by 2, mathematically they can always be merged. अब कैसे merge होंगे, कैसे बनेंगे d by 2 pairs, 4 पेयर कैसे बनेंगे बताता हूँ. देखो ये 4 है ना भाई. हाँ सर. तो ये C1 का पेयर C2 के साथ बन जाएगा. This node will make pair with this node. So this pair done, right? This node will make pair with this node. This node will make pair with this node. They are not having any child-parent relationship, so they are valid pairs. This node will make pair with C5. And this node will make pair with this node. So guys, see, all nodes are able to make pairs with each other. So in total, if there are d nodes in below 1, there will be d by 2 pairs na. But you should be knowing by guarantee that they can make pairs. ऐसा नहीं होना चाहिए कि pair नहीं बना पा रहा और तुम हवे हवे में लिख दिए. So how will you know if they can make pairs? Only if the maximum count of subtree of all of them is less than equal to d by 2. अगर maximum d by 2 से कम है, मतलब ये जो d by 2 जो आ रहा है, जो से कम आ रहा है, जुड़ सकते हैं दूसरे के साथ. So this is the basic concept which you need to understand, and that is the most important problem solving skill you need here. Okay. By the way, many type of these problems are in our course. So if you are there, hopefully you will understand what we are trying to tell you. Okay. So guys, we do post order traversal DFS. So we first travel the leaves, then upper nodes, and finally the root. So guys, for node 1, let's say C1, C2, C3, C4, C5 are the children of node 1. Count of C1 will tell us the number of nodes in the subtree of C1. Count of C2 will tell me the number of nodes in subtree of C2. Count of C3 will tell me the number of nodes in the subtree of C3. Count of C4 will tell me the number of nodes in the subtree of C4. Count of C5 will tell me the number of nodes in the subtree of C5. Calculating count is simple post order traversal DFS. So guys, what will be U? U will be count of C1 plus count of C2 plus count of C3 plus count of C4 plus count of C5. If the maximum of them is less than equal to U by 2, it means all these nodes can somehow form pairs with each other. So answer of 1 will be U by 2. Because U by 2 pairs get created by U nodes, and node 1 cannot be paired with any other node, as all nodes below 1 are at this node. Okay. So number of maximum pairs which can be created for tree rooted at node 1. Okay. Okay, you just need to be a little bit more careful. Okay, for example, if there would be odd number na, then also this problem will work perfectly. Now what is the D or U? 3 plus 2 plus 2, 4, 5, 6, 7. What is D by 2? Okay, what is the maximum? Maximum is 3 comma 2 comma 2 is 3, which is less than equal to D by 2. What is D here? D is 7. 7 by 2. Don't do the actual division. Don't write 3.5. 7 by 2 is 3. So write here 3. Okay. 3 is less than equal to 3. Okay. Even this can get solved. So here you can make 3 pairs. See? This guy with this guy. This guy with this guy. This guy with this guy. So one guy will get remaining and this will be remaining. But because we are doing D by 2 now, it's okay. The odd, or if the D is odd, then also the problem can get solved. And if the D is even, then obviously all nodes get used. But if it's odd, one node gets left out in the bottom. And if D is even, nothing in the bottom gets left out. Only the root node gets left out. Root node gets left out in odd case and even case both. But in odd case now, one node from the bottom will also be left out. And don't think that you can merge this bottom node with the root node, because root node can never come in any group. So guys, the problem is solved. But guys, there is one case which you guys did not think of. There is one case you did not think of. What if, this is one, right? You know that these guys are the children, right? 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 You know that D is nothing but count of C1 plus count of C2, like count of C1 plus count of C2 plus count of C3. Now, if the maximum of all of them, if the maximum of all of them is less than equal to D by 2, then you just simply say that dp of 1 or dp of this is nothing but D by 2. But what about the else condition? Guys, what if the maximum is greater than D by 2? It means that greater value will have to first merge with all the other people. Then we will think what to do with the leftover values, right? अगर वो D by 2 से भी बड़ा हो गया तो क्या करेंगे? बैठ के रोएंगे क्या? नहीं नहीं रोएंगे बेटा. So let's say the things look something like this. Okay. Now guys, see the problem. This subtree C1, this subtree C2, this subtree C3. What is the total D? 1, 2, 3, 4, 5, 6, 7, 8 plus 2 plus 2, 9, 10, 11, 12. So, like, ServiceNow always asks DP problems. Brilliant ones, that also. But guys, what is the maximum? Maximum is 8. Which is greater than equal to? Which is greater than equal to? Which is greater than equal to? D by 2. 12 by 2. So guys, this is a problem. Means we cannot merge all of them. Something will get left out. So I will try to merge this guy with this guy with this guy. They are forming valid pairs, no parent-child relationship or distant ancestor-child, descendant ancestor relationship. This guy with this guy with this guy. Even after all the merging, you can see that 1, 2, 3, 4, 4 nodes are left. 4 nodes are still left in C1 for merging. So guys, it means that whichever guy has the maximum frequency, first what you will do in the algorithm, whichever guy has the maximum frequency, find it out. You come to know that count of C1 has the maximum frequency. Now what you will do? You will find Z, or let's say you will find Z. Z means like instead of Z you will find P. P is nothing but what? Count of C1, which is the having the maximum frequency, minus count of all other people. So guys, what is the count of C1? 1, 2, 3, 4, 5, 6, 7, 8. 8 minus count of all other people, because other people are merging with us, na? So 2 plus 2, 4. So P equal to 4 means 4 nodes are left out. 4 nodes are left out. Now how to solve the left out node? So hopefully guys, whenever we have this condition, you will be able to find the P value. P means leftover nodes. Leftover nodes in the largest subtree. C1 is the largest subtree, right? So अभी जो 4 नोड बच गए, इनका कैसे सेटिंग होगा? What will you do for them? Answer of C1 will tell you the answer for that. Answer of C1 आपको बता देगा ना. Answer of C1 can immediately tell you. Answer of C1 can tell you how many pairs it can make by itself without needing anyone else. Wow, wow, wow. That's why we need to calculate the answer of bottom nodes first. Because sometimes we might need the answer of C1 when the frequency is becoming greater than D by 2. It is greater than D by 2. Answer of C1 मुझे क्या बताता है? How many pairs this tree at C1 can make without the use of C2, C3, anyone else. Okay. Because answer of C1 was calculated by thinking it as an individual. By thinking of it as an individual, the answer of C1 was calculated, guys. So answer of C1 क्या है? Let's say this is node A, B, C, D, E, F, G, H. Okay. तो आंसर ऑफ C1 में क्या क्या बन सकते हैं? In answer of C1, I think we can take D. Na. A comma nothing. We can take. We can take E comma H or E comma G. E comma H. E comma H we can take, guys. E comma H. Because they both are not having any relationship. Other all I think will have relationship. If the other will not have any relationship, because others are having ancestor parent thing. Okay, so in this whole tree which is rooted at node C1, you can only pick up E and H, because all other nodes if you pick up they will have parent ancestor relationship. Because I'm only considering the C1 part, I have forgotten all the other trees. Only for C1, if I want to do something, I can only pick up E and H, right? Or I can pick up E and G, or I can pick up E and F. No more than that. So answer of C1 is 1. Answer of C1 is 1. Answer of C1 is 1. This basically means that 1 into 2, two nodes are used. If we only try to solve for C1, only two nodes will get used. This node and this node. But how many leftover nodes were there in the previous calculation? 4 nodes were left out. 4 nodes were left out. But, internally you can use 2 nodes. So, P minus 2 times answer of C1 is nothing but the final leftover nodes. फाइनल लेफ्ट ओवर नोड्स. अरे इधर के 1 2 3 4 ये 4 नोड रह गए थे ना, बट हमको पता चला कि इन 4 नोड में से 2 नोड यूज कर सकते हैं. आंसर ऑफ C1 1 है, मतलब एक पेयर बन सकता है, मतलब 2 नोड यूज कर सकते हैं. सो P माइनस 2 इंटू आंसर ऑफ C1. सो वॉट एवर द नोड्स इन दिस विच कैन बी यूज्ड on their own, you should subtract them from P na, because they will never be leftover nodes. Now whatever is the leftover is the true leftover. उनको हम कहीं भी यूज नहीं कर पा रहे, ना उनको हम अपने अंदर यूज कर पा रहे हैं, ना दूसरों के साथ मर्ज कर पा रहे हैं. P minus 2 into answer of C1 is the final leftover. 4 minus 2 into 1, 2. Two nodes are never used again, anywhere. Which are those two nodes? Such a brilliant problem, my goodness. This node got used with 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 this. Then 4 were left, right? 1, 2, 3, 4. P equal to 4 were left. But then you subtract. Final leftover. Final leftover is nothing but P minus 2. 2 is nothing but answer of C1. Because internally you can use 1 and 2, na? So 1 and 2 got used. Only 3 and 4 are left. Only 3 and 4 are left, which is 2. 4 minus 2, 2. So you can say that dp answer of 1 or dp of 1 is nothing but the total number of nodes here. Total number of nodes here you were able to use, but 2 nodes you were not able to use. So d minus 2 by 2 is the answer. Wow. So guys, that is the solution, and this solves the whole problem. What will you do? You have this tree, you will use the formula which I taught you, right? First you will calculate the dp value of this, then you will calculate the dp value of this, then this subtree, then this. When you have the answer of dpc1, dpc2, dpc3, and this is the node 1, finally you will calculate dp1. dp1 or answer of 1 is the final answer. You will find the code, references, and the learning videos which you need to watch before watching this video in the Google document. Okay, hopefully you guys learned it all, and these things are in a lovely manner explained here also. Love you all. Ram Ram.